Okay, hello everyone. My name is Guohao Wang. I'm from UCL. So today I'm going to present a review paper titled by Enabling Human-Robot Collaboration in a Structured Construction Environment through Sharing Control. So focusing on classification, challenges, and future trends. So this is the ISARC conference, so I don't have to emphasize why we need robots in construction. So let's go directly to why we need human robots collaboration in construction. So if we compare these two figures, we can easily figure out in car factory, everything is fixed. So you know the position of the robots, you know the position of materials, and you even know the type of material of the components. So it means the uncertainty is really low. But in construction sites, we don't even know what's buried on underground. So it means high level of uncertainty. So the reason why the human robot collaboration is that we are not able to make the construction robots running full autonomously in unstructured construction environment. And so here I list several scenarios so why the human is perform much better than construction robots. So the first scenario is like if we're trying to generate a pause between these two rhinos, and as a human, you can easily give a pause just like this, right? And for the second one, if you're trying to grasp irregular material such as this is an irregular rock, and the human being can easily figure out the pose, how to pick it up. For the third one, if you're trying to reach the green cylinder, the very intuitive way to is just to push away the two right components in front of the green cylinder. And for the fourth one, sometimes even though we already have a full autonomous driving car, but sometimes you still need to take over and the complex situation such as bad weathers, complex road conditions, things like that. So this is existing literature review about human-robot collaboration in construction. So such as they propose some classification framework according to the level of robot autonomy, and they propose the multi-dimensional taxonomy, and they also review some application scenarios such as the different robot types, different construction activities, and different interaction roles. But currently, we still know very little about how exactly human intelligence and robot autonomy are fused together. So if we're trying to design a human-robot collaboration system, we still don't know how to combine them together. So the research objective is to understand how control or autonomy is shared between human and robots in existing human-robot collaboration system, and try to classify them according to the control sharing mechanisms and identify the challenge and the trends. So we adopt a systematic digital method, which comprises of two main steps. Which the first step is identification. Second step is screening. So for the identification, we use three types of searching terms, comprised of shared control related terms, such as human in the loop, supervisory control, semi-autonomous, and also robotic related terms and construction related terms. For the screening, we have three sub-steps. The first one is title abstract and the keywords screening, and afterwards the full paper review, and the last one is consists of the final list. And here are some results of this paper. We can easily recognize there's a rising trends in terms of the number of publications, and half of them from conference, half of them from journals, but most of them come from the IEEE series journal. And so the robots types used in this literature comprise of a robot's arm and mobile manipulators, which there's a mobile base and there's a robot arm on the mobile base, and mobile robots. So this is the key finding of this research. So we propose two main category of classification, considering about the shared control mechanism of human-robot collaboration system. So the left side is no autonomy, and the right side is the full autonomy. So the two main category, which is the human in the loop and human on the loop, sits between them. In the loop means the participants plays an active role in the robot control loop. And so compare with that, human on the loop means the robot is capable of running full autonomously, but it still needs some intervention when necessary. So this is the definition of that. And to get deeper, the human in the loop can be further divided into several categories: semi-autonomous one, robot-guided one, and the human-instructed one. So just give an example. So maybe the robot-guided one. So here the ISP represents sensing, blind, and action. So in this paradigm, the robots will not generate any actions, will not generate any commands to the actuator, but it will get the operator for the planning. Then the operator give the action, then give to the robots. So this is the mechanism how the commands build together. The flow human on the loop paradigms because human on the loop way the robots can run full autonomously, but it still needs some intervention depending on who initiated this takeover, who initiated the switch of robot control. We divide it into the human initiated one and the robot initiated one. After that, so this is the challenge and the future trends we identified in this literature in this paper. The first one is no matter which category you're trying to design, they still need some interface because the human always receive the feedback from robots and they give some control to the robots. So the intuitive interface is a challenge because there are mismatch of degree of freedom. And if you teleoperate the robots, they reduce the situational awareness. That's another problem. And low latency bi-directional communication means with the human in the loop, you are continuously give commands. If there is some delay in the communication system, so the feedback give back to you maybe the couple of seconds before, so it will give generate some mistakes here. And the trust between human and robots. So if you're trying to deploy a human on the loop system, which is a very high level robot autonomy, if you are trusted the robots to finish all the work. So the trust building is another challenge. So the two future trends are identified. The first one is if you're trying to validate this kind of system, there must be human involvement. So the high fidelity dynamic robot simulation with human involvement is the first trends we identified. Another one is multimodal human-robot interaction interface. So currently, most of the interfaces are still relying on one modality, such as just the controller or other types of modality. But how to leverage multi-modality, like the human perceive the world, is another research trend. Okay, this is the reference, and this is the contact code team member. I'm from UCL. This is my supervision team, and I'm working in the UCL robotics group. Yeah, that's it.